Imagine a feature designed to make your network life easier, faster, more efficient. But instead, it's causing headaches and baffling even seasoned professionals. We're talking about IPv6 compression, a seemingly brilliant solution that's quietly introducing some serious confusion. Stick around as we unravel why efficiency sometimes breeds unexpected complexity in the world of networking. What if I told you that a core feature of the internet's future isn't just misunderstood, but actively making things harder for the very people trying to implement it? We're pulling back the curtain on IPv6 compression rules, and trust me, what you think you know about efficiency might be about to get a serious reality check. Prepare to see how a good idea can go surprisingly wrong. Are you an IT pro scratching your head over baffling IPv6 addresses, wondering why something meant to be simple feels so unnecessarily complicated? You're not alone. In this video, we're dissecting the precise point where IPv6 clever compression rules stop being helpful and start creating major practical hurdles for network professionals. Get ready to finally understand the why behind the confusion. To understand the chaos, we first have to respect the sheer scale of the beast. IPv6 wasn't built for humans. It was built for machines. 128 bits of address space. That is 340 undecillion addresses. To a computer, this is paradise. To a human, try to type it into a router config. It is a nightmare of hexadecimal characters. An IPv6 address looks like this. 8 groups of 4 hexadecimal digits. It's long. It's unwieldy. So the engineers said, let's compress it. They gave us 2 golden rules to save our sanity. But as we will see, rules are open to interpretation. Rule number 1, the leading zeros. If a group starts with a 0, you can drop it. 0db8 becomes just db8. 0000 becomes 0. Simple, right? It's like writing the date. You don't write 05 THMA. You just write 5th. This is the easy part. No one gets hurt here. But then comes rule number 2, the double colon. This is the magic trick. If you have a long string of consecutive zeros, you can replace the whole lot with 2 colons. It's the ultimate shorthand. It turns a monster address into something short and sweet. It feels efficient. It feels clean. Here is the address before compression. And here it is after. We save space. We save typing time. On paper, this is a victory for network engineering. But notice I said on paper. In the real world, digital ink is cheap, but cognitive load is expensive. But there is a catch, a fatal flaw in the logic. You can only use the double colon once. If you use it twice, the computer panics. Why? Because it can't know how many zeros are hidden in the first gap versus the second gap. Ambiguity is the enemy of computing. Now, let's enter confusion zone. The problem isn't the rules, it's the choice. An address can often be written in multiple correct ways. Let's look at this address. I can compress the first set of zeros, or I can compress the second set. Both are valid, both will work, but they look completely different. Imagine you are troubleshooting a firewall log. Your security alert says the attack came from address A. You search your database for address A. 0 results. You think you're safe, but you're not. The attacker is there, but your database logged him as address B. Same digital identity, different visual mask. This is the string comparison trap. If your software treats IP addresses as text strings, which many legacy systems do, it sees these two formats as strangers. It doesn't know they are twins. This simple compression feature breaks search. It breaks filtering, and it breaks correlation. And it gets worse with operating systems. Windows might prefer compressed the longest run of zeros. Linux might prefer the first run. A Cisco router might do its own thing. You are now working in a Tower of Babel, where everyone speaks IPv6, but with a different dialect. Think about the cognitive load on you. When you scan a list of 1,000 IPs, your brain looks for patterns. Compression destroys vertical alignment. The columns don't line up anymore. Finding the anomaly in a list of compressed IPv6 addresses is like trying to find a typo in a novel while riding a roller coaster. So, the feature designed to make addresses human readable has actually made them human confusing. We traded length for inconsistency. And in security and operations, inconsistency is dangerous. Is there a way out of this madness? Yes. It's called RFC 5952, a request for comments that became a law of the land, or at least it should be. It defines the canonical format, the one true way to write an IPv6 address. The rules are strict. Compress the longest run of zeros. If there's a tie, compress the first one. Use lowercase letters only, no capital. This standard ensures that every machine and every human writes the address exactly the same way every single time. If you're a developer, a network admin, or a cybersecurity analyst, your job is to enforce this canonical format. Don't let your tools be lazy. Ensure they normalize inputs. If you don't, you are leaving the door open for the silent gatekeeper to get confused. IPv6 is inevitable. The address space is too vast to ignore. But the lesson here is bigger than just networking. It's a lesson in design. Just because you can compress something doesn't always mean you should, unless you have strict rules on how to do it. So, the next time you see a double colon in your config, don't just see a shortcut. See a choice, and make sure it's the right one. Thanks for watching. Keep your packets flowing, and keep your addresses canonical. Follow us and subscribe to the Expert IT365 YouTube channel for more videos.